Welcome student. Once again this is your Partho sir. Today I am here to explain a call by reference somehow in a deeper concept. In our previous class we learned about the call by reference using one basic common example. Now here I shall explain how you can have more than a single updated value in your main program without returning any value from the subprogram. Okay. Say for an example, you have a method called arith that will perform some arithmetic operations and it does not returning anything. So it's not returning anything. And at the time of call from the main function, I am sending the address of A and B and also sending the address of add, sub, multiplication, etc. Okay. Now the first question that comes in mind that I have the values for A and B here because I have taken from the outside. But what about these three variables? The sub, add, mul, or you can write division, then remainder division and anything. Okay. Now here what would be the value of add, sub and mul? Okay. So the answer is I am sending add, sub and mul the value as a garbage. Okay. So at the time of calling here I am sending the garbage value, but if there is any kind of updated value or any kind of updation performed in this arith function, then I shall have a updated value for the add, sub and mul. Okay. So the scenario is looks like this. Okay, say for an example, you have two variables A and B and 3, and the address of, let's assume, okay, the address of A is 100 and the address of B is 200. Now x or pointer x is pointing to the address of 100 and pointer B is pointing to the address of 200. Okay. And what about these variables? I have not taken any value for this variable. Okay. So here basically I am sending nothing or I am sending a garbage. Okay. That address of this add, sub and mul is being received by the corresponding pointers. Okay. And if any updation is performed here, that would be reflected in your main function. Okay. So that is the advantage of using call by reference. Okay. Let's come here and let's check how we can do this. Say now go there and try to defining this function. Okay. If I write down my pointer x or the value of x equal to my pointer add, that's mean the value of add is pointer x plus pointer y. Okay. Now if I write down my value of subtraction equal to pointer x minus pointer y. Now if my value of multiplication m equal to say pointer x into say pointer y. Okay. And I am not returning anything from here. Okay. The updated value automatically will reflect here. Okay. Let's check whether it's reflecting here or not. So if I write down printf, printf say is n equal to say percentage d backslash n subtraction equal to say percentage d say backslash n multiplication equal to say percentage d. Now if I write down these values, so at first say add, then sub, then I'll say. So just it, you no need to do anything more, because here we have performed a call by reference technique. Okay, let's check, just save it. I try to run it. Okay, so enter two numbers, say I am giving the same value 12 and 3, so it is showing my addition is 5, subtraction 9 and multiplication 36. Okay, that is running perfectly, only because here I have sent the address, and this address is being received by this A and B is being received by X and Y pointer, and then this 3 address is being received by this 3 pointer. Okay, something like this. And if I am performing any updation here, that is by default reflecting in my main function. Okay, so that is the advantage of call by reference. Okay students, thank you for watching.